Sometimes analysing a circuit is incredibly easy and can even be done by inspection, provided you're not a complete idiot like this guy. Unfortunately, not all circuits can be solved this way. In an effort to make life easier, a French scientist in 1883 by the name of Léon Charles Thevenin figured out a way to simplify circuit analysis. He derived a theorem which states that any two-terminal DC network can be replaced by an equivalent circuit consisting solely of a voltage source and a series resistor. Now there are 5 steps to applying this theorem, and they are as follows. Steps 1. Remove the load component from the circuit and mark the terminals with A and B. Step 2. Replace all voltage sources with a short circuit and all current generators with an open circuit. Step 3. Now find the resultant resistance of the circuit by collapsing the circuit into one series resistor. Step 4. Calculate the Thevenin equivalent voltage at the terminals by reinstating the removed voltage and current sources. This will likely involve nodal analysis. Step 5. Redraw the Thevenin equivalent circuit, including the load resistor, usually denoted by RL. Let's have a look at how this works in an example. In this circuit, we have an arrangement of series and parallel resistors connected to a 12-volt power source and a 2-amp current source. If we want to determine the current in the 4K ohm resistor, we need to apply Thevenin's theorem to this problem. The first step will be to separate the circuit at the 4K ohm resistor. The portion of the circuit on the left will be transformed into a Thevenin equivalent circuit. The next step is to apply the 5 rules for constructing a Thevenin circuit. So first up, we need to replace the voltage source with a short circuit and replace the current generator with an open circuit. Now we need to consider the circuit as though looking from the terminals A and B. From here, we can easily see that we can simplify the network by combining the resistors, giving us a resultant of 1.5 kiloohms. This is our Thevenin equivalent resistance. Next, we need to determine the voltage across the 3K ohm resistor. We can do this using nodal analysis, and with a little bit of maths, we get 2 equations which, when solved simultaneously, show us that the voltage at V2 is 7 volts. We can now reinstate the 4K ohm resistor and use basic Ohm's law to determine the current flowing through it.
That's all, folks.